All right, I'll try to keep it high level and give you the most important details of this one. Um, Basically, it's about once you have generated data or you want to store data for the longer term, in our at Pawsey, especially big data that you cannot simply download to your local drive for long-term storage. What can you do? Because Scratch, the file system we have discussed so far, have policies such that the contents of them on Scratch, there is a limited amount of time you can have files due to the purge policy. After 21 days, they will be deleted unless constantly used. And on software, you can only store software and scripts, so not really data you produce or you need to use for your computations. So Pawsey will provides what we call Acacia. Acacia is an object store system. And throughout this module, I will describe what is an object storage, why we are using it instead of a file system with an unlimited time on it, or how you can set up access to Acacia to store your data, and how to store, retrieve, and share data using Acacia. Okay. So usually in our workflow involving a supercomputing facility, and especially Pawsey, we start with data. Well, not all the workflows, but a typical workflow, an example here is the one from radio astronomy, is that data, a large amount of data to be analyzed is ingested in the Acacia object store. You can see it, you can see now as a long-term storage for data. To process the data, though, you cannot simply read data from Acacia. You need to move data from Acacia to Scratch, the file system Chris discussed earlier. Once the data is on Scratch, then Cetonix can read it through the normal system calls, and your program can read files on Scratch, just like you read files on your computer. Once the input is read, is analyzed, and some output is produced. This output usually can be quite big as well. So you want to have a place where to store your output as well. And this is, again, Acacia. An object store system which has a lifetime for the entire project, so you can keep it there, input and output, as long as you want during the lifetime of the project. If you want to visualize your data, there is also you will also have to move the data from Acacia to Scratch if it's not already on Scratch, and then you can use the visualization nodes to visualize the data. So this is a typical, what we expect people, researchers do when using Cetonix and the Pawsey infrastructure. So Acacia is a high-performance, large-volume object storage system, and as a user S3 interface, which is basically a protocol that was developed by Amazon to store and retrieve data from the Amazon S3 buckets, and it's been adopted worldwide in other use cases such as object storage for on-site storage system like Acacia. What that means essentially is that you're going to use this S3 protocol to download and store data from Acacia, and you will use client implementing these protocols. But you cannot, your programs, unless using this S3 protocol, cannot read and write directly data to Acacia, like they do when reading data from the file system. The advantage of using this system is that the way it's organized and designed allows for a large amount of data to be stored, like 60 petabytes, but currently we are planning an expansion to around 130 petabytes, I believe. So a large amount of space made available because of the architecture of the object storage. So what's an object storage? How does it compare to a file system? So a file system is, as you might be familiar with, is a directory, or is a hierarchy of directories and files. Files are organized in directories, in possibly a hierarchy of directories, and then each file contains characters or bytes, data. The fundamental unit in a file system is the byte, because the byte bytes are collected in a file. These bytes can be characters or can be binary data. You interpret them as you want, and they are cohesively stored in a file. If they, semantically they have to be together, and then these files can further organize in directories. This should be nothing new to you. And then you can read a file, you can index bytes within a file, so you can move around the file. And so a file is not a unit, the byte is the unit in the file system. Instead, an object storage is a system where there is no really a hierarchy. There is what is provided is essentially a flat hierarchy, essentially. Just you have buckets, the concept of buckets, each bucket containing one or more objects. An object is, you can see it like a file, but the one difference is that it's an atomic unit, meaning that you cannot read portions of an object. You cannot modify portions of an object as you modify portions of a file. So an object is an object is the basic unit in an object storage. To modify an object, you will have to download it on a file system where it becomes a file, so you modify it, and then you store it back. In an object storage, you have the Acacia, in this case, represented by this cloud here. And then you can create one or multiple buckets in this system. These buckets will have unique identifiers, and then you can place objects in these buckets. And that's much about it. You cannot have a hierarchy of buckets. You cannot create a bucket within a bucket to organize your data, just like a file system. So this lack of structure is what allows the system to be so scalable, because it's much simpler than a file system. It's being much simpler. It's also less expensive to maintain and the software to develop. That's why, with the same money, you can buy much more storage with an object store instead of paying for a file system, which is not only disks and SSDs to store data, but also complex software to manage all of that. So what happens is within an object store, a bucket has to have a unique name across all Acacia, all the object store systems. So if you try to create a bucket named test, you probably fail because there is another bucket from another project that called the bucket test. It's one of those common names you can use and someone has already thought about. Any questions so far about this concept? Okay. So it's basically a compromise between high performance, capacity, and cost. So these are the benefits. You have high performance in terms of transfer speed and the capacity you can have there and the cost of the whole system. But the downside is that you cannot natively create this hierarchy of files, organizations such as the file system. You cannot modify objects in place. If you want to modify an object, you need to download it on the scratch, modify and store it back. Acacia is a system separate to Cetonix, so you can communicate with Acacia through this S3 interface protocol, or I think there is also a web interface. So it's a system that is usable not only from Cetonix as a project store system, but you can also use it from the external world. You can upload and download data from Acacia, not using Cetonix, but your laptop as well. Let's say you have produced data using Cetonix, and then from Cetonix you store it to Acacia. You can download the data from Acacia directly to your laptop without going through Cetonix. In that sense, it's independent of Cetonix. And you can also use shared packets through links, through web links. You can generate web links you can share to other colleagues so that they can download the data you've generated. Okay, so you have each project, when it is awarded time on Cetonix, usually it's also awarded some space on Acacia. I think the default is 1 terabyte for 1 terabyte for each project and 100 gigabytes for each user. That's the default allocation. But to access Acacia, you need to set up your credentials. So you go to this website, this portal, and what happens is it will ask you to generate access keys. Every time you want to perform an operation on Acacia, you will basically need to provide this access key. This access key will be used to form authenticated queries to the system, so that Acacia knows it's you and you have the right permission to read and write these objects. Actually, once you will be normally using an S3 client, so a client that is able to communicate with Acacia, just like similar to rsync or SCPUs to communicate with Scratch from and to your laptop. You can use these clients, I will list them later, to communicate with Acacia. These clients have configuration files, and these configuration files stored in your home directory will contain this access key, so that you don't have to type access keys all the time, but the client will use these configuration files to perform the authentication. First, you need to get these access keys, though, and you do so by going to the portal and to the tab Acacia here, and then it will ask you to generate a key for the storage in space you selected. As I said, each user has its own storage on Acacia, but also each project has its own storage, which is accessible to all people within that project. So we need a different key for your own personal space and one key for each of your projects. Once you generate the key, the portal will actually also give you an example how to configure the client. So what you normally do is basically you generate the key and then you copy the example script that is provided here. You will run it on Cetonix and that will configure the access for that specific client. rclone is the client that we recommend to use with Acacia on Cetonix. It's already available on Cetonix as a module. So if you do module avail rclone, you will find that software. And this web interface, once you generate the S3 keys, it will generate a script that you can execute to set up your configuration, then access your storage on Acacia. There is a documentation for this, so and you also have slides available. You can go through them with calm. If you have problems, you can always contact us. Of course, never share your Acacia keys with anybody, and don't embed them in your scripts. It's only stored in your configuration file in your home directory. The home directory is only accessible by you. Okay, so S3 client. An S3 client is basically a program implementing the S3 protocol. So we suggest rclone, and we will show some examples on how to use this. Okay. So the configuration file for rclone is here. If you run the script as the interface adjusted, it will all be created for you, so you don't have to do really much for it. This is an example configuration. You see the configuration will have a remote name. You will use that remote name to refer to this remote storage when you use rclone. See some examples. Here are a few examples. Once you configured your access to the system, you can load the rclone module, and the executable is called rclone, and then the other commands here are various commands you can perform on Acacia. rclone mcdir remote name bucket name will create a new bucket. So the remote name, and then you have these two, this column. This will indicate that you're trying to now access a remote service, an S3 service, and then the client will go and look at the configuration file and look for the details of this remote and how to connect to it. The remote name in your case could be your username or the project name, because those are unique. Those are unique to your project, and those are used to identify the associated storage on Acacia. Then you specify the name of the bucket. As I said, the bucket name must be unique to all Acacia. This is a requirement dictated by the object storage, and can be hard to understand. Okay, how do I know if this name is taken or not? Well, if you try to create a bucket with a name that has been already used, the command will silently fail, so it won't really complain. But you see that no bucket has been actually created. A good practice would be to prefix the bucket name with your own username or a special code sequence that it's uniquely yours. In that way, you won't have that problem, hopefully. You can also list all the buckets in your remote with rclone lsd, and ls lists all the objects in your bucket. Okay, let's see if I can actually have some examples here. I will try to run some of these commands myself, but I do have my from Cetonix. You don't have to run from Cetonix, but since the client is installed on Cetonix and I have all configured on Cetonix, I just use Cetonix. Rclone, tab completion, CC. Now rclone lsd. So I want to restore the directories or the buckets in my personal remote. So my personal remote is with my username. Now, if it's, I don't remember if it's configured with that. Okay. So I do have a remote here with my personal username. So this is my own bucket. And I do have a few buckets here. So if I do, what happens if I do just ls of this one? It lists all the files I have stored here. So in this bucket, which is called obs, these are radio astronomy observation. These are parts of the observation. So what with the data collected by the telescope, and you can see they look like files, but they have a name similar to files. But what I can only list them and download them or upload them. I cannot modify them. So these are objects that are immutable while they're sit on Acacia. And so on. So you have a few commands here. You can run. You can remove a bucket. You can list the objects as we did, and pretty much all the operations the basic operations you may think you're already used to on a file system. Already said that. There are a few conventions and few do's and do not when you create buckets. So the file name, bucket's name cannot have capital letters, underscores, spaces, or special characters. So this is about buckets, not the objects in the buckets. Okay, so this is basically the example that I just ran from my command line. What happens here? Okay, if there are existing buckets names, then as I said, if you try to create a bucket that is already exists, it fails silently. If you try to access a bucket that you don't have access to, it says access denied. So what's the approach to store your files? You're on a file system from scratch, you produce some files and data. How you are going to store on Acacia, and how you how you want to organize them on Acacia, given that you cannot create native hierarchies in object storage. What's the approach you can take? So you can copy single files as objects. As I said, objects are like files, but they cannot be modified. So once you take a file, you copy it in a bucket, that becomes an object. So this is useful when a small amount of data is to be transferred, and it's also useful for testing. You can also compress all the files, create a single file, a tar file, or multiple tar files, and you copy them in a bucket. So you have maybe your own directory, a hierarchy of directories. You want to tar them. You can tar them and then transfer tar file, a single object, to one of the buckets you have created on Acacia. When you download them back, you untar the file, and then you get back your data. So the other approach you can take is to mirror or synchronize a full directory tree into a bucket. Now, I've just said that you cannot create hierarchies in the bucket. So how can you do? Can you mirror or synchronize a full directory hierarchy on a file system to Acacia? Well, the client, what it does under the hood is flatten the hierarchies. So if you have a hierarchies of directories, they all go into the file name. So what happens is, if you have a file A, or you can a file name, let's say name a file in the hierarchy of A, B, C. So the directory A contains directory B, which contains directory C, which contains the file named file. So what happens is that the file name becomes A special character, B special character, C special character, and then the file name. So you flatten the hierarchy and it all contained in the file name. So that's how it does. And it does so by choosing a special character as a separator. At the moment, I'm not really sure which one it is, but that's the trick it does. And when it tries to copy back these hierarchies from the bucket on Acacia to the file system, it creates back the hierarchies of directories based on the file name or the object name. rclone does this in a transparent way so that you can just use this rclone sync command to sync the hierarchies on the file system to the object store. It might be less efficient in terms of transfer speed than the work the client has to do. There is also some limitation because there is a limitation on the number of objects you can have in a bucket. You can have multiple buckets, but each bucket, I think, has a limitation of 100,000 files in a bucket. So you cannot mirror a very large directory tree with many files in a single bucket. It might be the case. Any questions so far? Yeah, a few other comments here and there, but you can use the copy command to copy files and all the files within a directory in a bucket. So this is some examples you can do. In this case, you're copying the files within originals. You're copying on your Acacia bucket named. So it's actually, so the bucket is called nickname Pawsey training, right? But then it created the structure, copy, like simulating the structure of the directory here. So it created the storage one, and then it's copying within storage one all the files. But it's essentially a single object. Because some of these operations won't have warnings and won't have, if you are unsure what's happening, with one command or not, you see that in this example, before actually executing any command, we can also use this dry run option which essentially simulates this execution of the command, and you see what's actually happening if what would happen if the dry run was not specified. So before deleting something, you try that dry run and see, and you say, instead of deleting, says I won't delete this file because I delete this option. But if you don't specify the option, then our clone does delete these objects. And if you try to list the content, there's not much there because we delete them. Once you delete them, they're gone. Okay. Oh, here is a few examples on how, again, we create a tar file here, and you can just copy the tar file to Acacia. Oh, well, actually, we have it on Acacia, and then we copy it back on the local file system. Okay. Well, you can use this rclone in a very complex fashion in your workflows. I don't think you may experiment with this in your internship. This is quite our advanced use, but what you can do is you can use the copy partition to submit jobs specifically to download or upload data to Acacia. Once you have these jobs, you can set if these jobs are needed to be executed before your actual computation, because you need to have the data on the file system, for instance, before running the computation. You can specify a set of dependencies between jobs such that your computation won't start until the other job, the download job, has finished. So you have to wait the download to be completed before starting the actual job. So this is the kind of things you can do combining Slarm and Acacia. You run the copy on the copy partition, also specifying multiple calls for each rclone instance, such that it can copy multiple files in parallel, speeding up the copy process quite significantly. And this is an example how you can create a dependency between jobs. You can come back at this. It's rather complex. So what happens is you submit a stage data script that basically will, I assume, call rclone to copy data on Scratch. What happens is once you submit the job, you want to get the job ID of the just submitted job. So that's the job ID of the job downloading data. Then you say, okay, the process data script will be submitted, but will only be executed after the dependency is completed. Okay, so after has completed successfully, and you specify the job ID that has to be completed successfully, then after this dependency is resolved, then you can start this processing. So this part won't start until this one has completed successfully. And again, similarly, you can store the results back only after the processing job has completed. So this is the kind of thing you can do with Acacia. Okay. I think we're running over time, so probably this one we will skip it, but you can also create a link. As I said, you can create links to objects and to objects such that you can share the link to other people outside Pawsey as well. They can public link with they are public link with an expiry date, such that anyone with that link can download the data. If you need to share your results with someone, you can create a link and set an expiration date. The maximum default is a week, and you can share the link with anybody, and they can download the data directly from Acacia. They only need the link. They don't need to have rclone or any clients, because the link provides a web interface to the download. They will download them with the browser. Okay, I think we come towards the end. Is there any questions on Acacia? It's quite a lot to take. I went through it quite quickly, but essentially it's a way to store data on the long term for your projects.